So let's go ahead and start this morning together. Welcome everybody. Thank you so much for being with us today on this hot summer day in Rome. And thanks for everybody who is joining us online. My name is Roberta Fabrizi. Yes, welcome to Spazio Europa. My name is Roberta Fabrizi. With me today is my colleague Rita, who is our event coordinator. I will be your moderator for the day. Rita and I will make sure that the morning and the afternoon run smoothly and on time. So if you see me looking at you intensely, make sure that you are respecting your time slot. If you have any questions about the venue and if you are joining online and you have any issues, please don't hesitate to let us know so that we can address it immediately and our technical team will support you. We have Ruben with us today who will be taking some pictures and videos, so make sure that you reach out to him, and we'll probably ask you a few questions afterward during our break. No worries, he's very friendly, I promise. Yes, once again, bear in mind we have many colleagues joining us online, so when you are speaking, please make sure that you have a microphone on you, otherwise people online will not be able to hear you. And yeah, that's it. That's a housekeeping out of the way. So let's start. So today marks the culmination of 3 years of Horizon Europe funded research and innovation. We still have a few months to go. However, you have noticed we didn't call this a final event. We called it an impact event. This is on the one hand to highlight the innovations that MobiSpaces had brought to the data spaces and green mobility domains, but also to look to the future of the ecosystem and to what the legacy of MobiSpaces will be like in the coming years. So this is yes. This is our agenda for the day. So you see we have a very packed morning, and then in the afternoon we will have a co-creation workshop. We will shortly hear from our coordinator, and then you will have the opportunity to learn about some of the MobiSpaces use cases, as well as our technical innovations and infrastructure. And then we will have a panel discussion with some guests here today, which you will hear about later on in the morning. I will not steal any more of your time with introductions. We'll dive straight in, and I will now pass the floor to Matteo Falsetta, the project coordinator. Yes, there we go. For an overview and introduction. Let me just set up the slides for you, Matteo, and I'll give you the floor.
Thanks a lot, Roberta, for the introduction. And thank you all for being here. It's a pleasure to have this event. And thanks to the event manager, Rita, and to our moderator, Roberta, for coordinating the activities of today. My pleasure will be to introduce you to our project, that is MobiSpaces. So our aim is basically to deliver a mobility-aware and mobility-optimized data governance platform that can somehow complete a data path that is supported by AI processing, and also gathers data in a fair way, also considering different aspects such as green best practices, trustworthy and privacy preserving pipelines. So this is a kind of holistic data governance platform, the one we are in charge to build, and that we have been building for the past, well, nearly 3 years now. It's been a great journey, and as you can see from here, we have some pillars of the platform here. So the AI-based data operation toolbox, the Edge Analytics Suite, and itself, the data governance platform that coherently support our realization of the platform. So basically what we do is try to enable a mobility data space through a connector, and we do so via the platform that is implementing declarative querying, decentralized data management, and online data aggregator on one side that is supported by AI-based processing. And on the other side, we have explainable AI prediction modeling and visual analytics that through a federated approach allows us to have actionable insights, because that is what it's all about. Via gathering sensor data through different devices, we will see that also with the presentations of our use cases. And the data governance platform overall respects verification, interlinking, cleaning, risk modeling, provenance and security, as I said, and privacy throughout the whole pipeline. So this is what is it all about. And this was possible thanks to the effort of 25 partners overall. So it's quite a challenging consortium in terms of the numbers, but in terms of the operations has been always pretty smooth, thanks to the very collaborative spirit that we have been having throughout the project. So I really want to take this occasion once more to thank all the partners involved in this amazing project. Of course, being the project coordinator, I will always say that it's amazing, you know. So it started in September 2022, and it will finish on the day of my birthday. So on August 25th, 2025. So it's going to be a nice date. Something, of course, I'll be sad by that. So it's not going to be a gift for my birthday, but in any case, you know. As you can see, we have different kinds, of course, of players, SMEs, big corps and research centers, as per usual in Horizon Europe projects. We have some big names, but in any case, except that the ones that are not that well known from you have been contributing in a very significant way. So let's not just get attracted by the big names. The whole team has been very valuable. So now we'll have a just quick overview on the use cases, and we'll have the chance to deepen 3 of them out of the 5 we have, representing 2 domains, the urban mobility and the maritime mobility sectors. On the urban mobility sector, we have 2 pilots that are led by, respectively, BOSCH and AMT. And the one of AMT deals with predictive maintenance on bus fleet. The SmartSense, led by BOSCH, is in charge of further understanding the effects of pollution, of course, produced by the mobility in the city of Thessaloniki, and also trying to analyze the air quality and the mobility data in order to have more efficient routes, possibly, to have an impact on the municipality. So that is a very interesting use case, because there is a municipality involved that is directly impacted, well, as well as the AMT use case, but in that case, the link between the municipality impact and the work done so far is not as immediate, let me say, as the other one. And then we have the maritime domain, represented by Kepler, GST and Frequentis, and they are collaborating basically on a more efficient tracking on dark vessels, so the vessels that sometimes are not spotted, let's say, in the ocean, or in any case in the sea. And we monitor also what is the state of the coastal area, to try to further understand with via bathymeter tools, in any case, bathymetric approach what is the depth of the sea, and also what is below there. So to try to understand what routes can be safer, for instance, or in any case more efficient, and this has a direct impact on the commercialization, among others, of products. And Frequentis is collaborating as well on the monitoring and data gathering from the sea to the land, to further intervene also. That's why I said actionable insights, because there is also lives involved, in the sense that via some of these tools, and thanks to the platform, we aim at having an impact on the overall awareness of what happens in the sea. So this is a nice challenge we have been facing, and by dealing with it, we have had an innovative approach and a highly innovative impact. So I'm very proud to show it to you after this slide, because this slide is about the impact creation, which is a huge word to say, but I'm really proud to say that we have had an impact. This is something that not all European projects can affirm, because we have been dealing and curating a relationship with standards and legislation bodies that is pretty tough, given the bureaucratic approach that typically we face in this kind of actions. We have involved more than 15 authorities and impacted more than 60 organizations. And through our pilots, mainly, we have reached an impact on over 60,000 citizens. These numbers are not, simply put there. All right, this is they went through careful assessment. Let me just give you an example with the Thessaloniki use case. By having our white boxes, and you'll see the presentation later, we had a direct impact on an entire area, of course, of the city, of the municipality. So we have simply taken the number of the citizens that are living in that area, and that is a concrete way of assessing this kind of impact, because the choices that will be made according to the data insights from the data governance platform and via the white boxes will lead to optimizations, to different kinds of actions and choices that will lead to hopefully better quality of the air, which is something not to be given for granted, and also possibly reducing traffic jam. And there is the community of researchers that is greatly represented here by our partners. That is the engine of progress. So I'm very happy that we have been collaborating with this huge number, 550. And thanks to them, we have been as innovative as we have been. And the detail can be seen here, because this achievement is something really, really valuable, because the European Commission has recognized that we had produced 6 key innovations. 6 key innovations. That is something. Here you can find brief descriptions. We have impacted benchmark mobility, the trajectory data sets via an efficient file format, federated learning for enhanced vessel route forecasting, trajectory algorithms, so an open source library for mobility data management, anomaly detection via enhancing anomaly detection with federated learning, and last but not least, the smart resource allocator, so optimizing AI workflow deployment across clusters. Of course, per se, you might not perceive the importance of these tools, but if you consider the overall picture, the greater picture, and hopefully at the end of today, you'll have it clear, you will further understand what is the true impact of these innovations. So with no further ado, I really like to thank you for being here, and for the online participants, thanks a lot. I would have loved to have you here face to face, because it's always a different kind of experience, but in any case, I'm really grateful because you are taking your time to deepening our project, and I think this is really nice. So thank you all. Enjoy the rest of the event. I'll be here, of course. I'll be available later in case you have further questions, and you'll see me again at the panel we'll have later. So thank you all.
Thank you very much, Matteo, and thank you so much for being perfectly on time. So I will now pass the floor to our colleagues, as Matteo told us already. So I will invite our urban mobility use case leaders to come to the podium. More specifically, we will start with Enrico, who will now be presenting the iRoute use case. Enrico, the floor is yours.
Hi everyone, I'm Enrico Buzzo, and I work for AMT. AMT is the public transport operator of the city of Genova, and we work on this project because we want to better understand how we can manage and use the information that we have in our company. For the first, the very important part is related with our e-bus fleet. We have more than 900 buses go around the city of Genoa, and now we are close to 150 full electric bus. And so what we understand during these last 5 years then is the beginning of our translation to move to the bus electric fleet is related with the importance of understand how we can manage that and how we can use that, because they aren't normal buses like we know. And the second part is related with our data, because during our long life, we collect a lot of data to try to understand. We have more close to 30 million of kilometers that we made every year, and we have close to 15,000 trips a day, and we collected all the information related with our work. And so, as you can see on this slide, we have we want to understand how we can collect, combine, and understand the information that came from our AVM system, from using the GTFS data that are now a standard and all the company can use and analyze that, and also to understand how we can manage the information that come from the CAN bus that are on our buses. So why we want to understand and how we we want to use that because we want to make a close better data analysis, we want to rescheduling better our works, and we want to make a prediction of the battery lives. That is very, very important for our works. The first here, I think, that we work on with the partner of the project is related with the analysis and the combination of the data, and to try to understand how we can use that related with the work that every partner can make on this data. We work very close with ENG that work a lot and with very difficult at the beginning to understand our data. As you can see on this slide, we try to understand how we can use that related with the single part that all the partners made on the MobiSpaces platform and all the engine that can work on this data. And so the first time, as I said, is related with the data organization and to select which are the data that to use in this case, because we cut a lot of data that are too much we have a lot of impact and not a lot of useful and is not so important to make our works. And so we work on these three parts, as I said, GTFS, AVM and canvas data. And the first part of the results is is a very important goal for us, that is the optimization solution. So analyzing the trips every day of our bus fleet electric, and how the battery works during the day, which are the passengers that are on the bus, the characteristic of the trips and of the route, and the partner ENG make an algorithm that make the possibility to optimize the solution of the trips. And so we can replan the information and replan the trips not for the day after, but when we make the rescheduling of our trips. Another very important part is the analyzing of the battery health, because we have two information that come related with the battery. One is one come from the bus. On the CAN bus we have the information of the use of the battery, and this information we collect every 5 minutes the information related with the battery. And but when we aren't running on trips and we are in our garage, in our depot, we make the charging of the battery. And we have two depots that now have the possibility to charge the battery with different technologies. And so we analyze how is the possibility to understand how does it work every single bus when they make the charge, because bus that seems are the same and a recharger that seems are the same are not the same. And so you can see on the slide that every bus have work not in the same way. And this is very important to try to optimize the maintenance of the part of the batteries. And a result that is not for related with EMT, but is for our passengers, is is the possibility to collect information and make more information for our passengers to understand when, where they can have the interchange with the train that is not managed by AMT, but we collect all the information and we try to make this available for our passengers. Okay, thank you. I'm here for every question. Okay.
Thank you very much, Enrico. And if possible, we'll take questions at the end. I would like to invite Mario to the stage now to present the SmartSense use case. This is also another one of our urban use cases. Mario, the floor is yours.
Hello everyone, my name is Mircea Mario, I'm from BOSCH, and I will try to present you the use case SmartSense. Let me also grab this. Perfect. So I think that Matteo already gave you a very good description of the use case. I will see if I can, let's say, give you more details about that. So basically the goal of the use case is to understand how air quality is working in Thessaloniki, and we want to find smart ways to improve the traffic and emissions in the city. Yeah, maybe I can also tell you a little bit about my partners. So we have Mircea and Fujitsu, and of course all the partners from the consortium. And I also have here with me a technical colleague. Her name is Andrea. So thank you for being here with me, Andrea. And yeah, let's jump into it. Oops. Here you can see on the left part, you can see pictures with the sensors which are installed in the city of Thessaloniki. We have a total of 9 sensors located there. And on the right side, you can find a picture with the sensor map. Quite interesting and yeah, good. Okay, so what you can see here is basically the plan or the steps or the actions that we do within Thessaloniki. So everything starts with the city part. So we start with capturing the traffic emissions and situations. Then we do some air quality calculations. This is called dispersion modeling. After we get the chance to see the information, then we plan with it. We find smart measures to take. And then we create some traffic management scenarios in which we can see, or at least we can understand, what are the better ways to improve the air quality. For example, we have, you will see on the upcoming slides more information about this. We have 9 traffic scenarios. For example, I can tell you about city bands, low emission zones, and so on and so forth. You will find details about it. And then everything is, it feels like a constant loop. So yeah, we start again with capturing the traffic emissions. Here you can see also in the similar manner as the previous slide. On the left side we have 3 pictures, with one with the sensors, then is one with the traffic emissions, and lastly you can see one of the final outcomes of the project, not of the project, of the use case, air quality heat map. And also on the right side you see the architecture behind it. So there is emission coming with the traffic emission, then they are going into the cloud, and then we are doing some data enrichment through different work packages, for example, work package 3 and then work package 4, and also, not the least, the front end, in which you can also visualize some of the results that we achieved. So, yeah, how a heat map is working, or what really is behind the heat map. So, we use different data sets. For example, we have the weather data, the Matteo data. With this kind of data, we generate a catalog of simulations. This catalog of simulations is going to be enhanced with the emissions that we receive from our partner Mircea. Also, in the same step, we also add the air chemistry into that. And Then we do what is most important, the kriging universal process. In this kind of process, imagine that, for example, on the left side, you see in this catalog a vague green field or a green part, and which we do in this third step, we do an interpolations with the sensors, and we try to define value, because on the left, the value is considered as 0, and we're trying to improve to get better accuracy for our model. And this is what we are doing on the kriging part, in which we also add the air quality measurements, so the measurements that we get from the city. And last but not least, you can see directly a heat map, and what's cool about it is that you can see the hotspot. For example, we can see in this old heat map, we also have new, you can see a hotspot in the intersection. I think in the upper part there is an intersection in which you can see a hotspot, and yeah, that's then going to the API. Yes, so I know that we will have a demo from my partner and colleague Niels, but I also try to tell you about how it will look like on the front end of the project. So we have, I think, 4 widgets, which you're going to see here. One widget is about the sensor map. In this widget, we received help from UPRC with the SparkWheel integration, and we successfully achieved to make a cool feature related to triggering the data with SparkWheel integration and RDF triples. Then you will see what I think is interesting, the traffic scenarios that I've tried to tell you about a little bit earlier. So you will see a heat map on the right, and on the left there will be a description of what you're seeing, and then you can understand what's going behind it. And then, of course, if you're an environmental officer, you can try to think about a decision which might improve the air quality of the city. And also there is a widget with basically the emissions, an emission map. I will present more in the demo. Yes, so last but not least, once again, some closing remarks. We are trying to make easy for everybody to understand how air quality is working. We also try to find measures to improve the quality of the air. Yes, another important thing would be to record the hotspots, so we can see if there's a decline or if there's an enhance in the emissions. And yeah, to take smart decisions through being data-driven. And what's most important, I think, it's to make air quality somehow understandable for everybody and to make it everyone's business. And yeah, not just a technical issue. That's it. Thank you.
Thank you very much, Mario. I will pass quickly the floor to Niels to discuss one of our maritime use cases. So Niels will present the CrowdSeaMappring use case. The floor is yours. Thank you.
Thank you, Roberta. So yes, I'm the only representative here today from the maritime use cases, but I will also shortly just say a few words about the other 2 maritime use cases. This is use case 3. Oh, right. Really, I'm taller. So what they have been doing in use case 3, marine traffic tracker, is combine the input from the automatic identification system, or AIS, with radar signals that you use for navigation. And by doing that, they achieve a higher fidelity of data rate, so you can actually track the ships much more closely. And of course, they're using federated learning to do the sensor fusion and tracking and vessel forecasting of where they are. So this is a very cool use case. The other use case is Vessel Edge. It uses AIS again, but AIS is line of sight only. So this means that once you're out to sea, you are not seen. unless of course you're in the range of other ships. So for the shore near and traffic planning and all this stuff, they're basically invisible. But what MobiSpaces proposes to do is set up a relay station, so to speak, where you can actually take the AIS messages, combine them, sort them, do some data cleaning on the edge, and then repost that to a server on shore. So yeah, that's it. And I will let the demo do the talking, and I'll take a glass of water, and I'll just play that now.
This is a story of how we slayed a sea monster. Not the kind of story from old sailor legends, but a very real challenge looking at our modern oceans. We faced the unknown in forms of gaps, assumptions, and interpolated data on our nautical charts. In Danish waters, more than 71% of data is actually interpolated. And this is where MobiSpaces use case 5, CrowdSeaMappring, comes in. Hydrographic surveys are conducted to make sure areas are safe for navigation. But at the current pace, and with current technologies, it would take more than 100 years to fully survey all of these waters. Some of the data we rely on is more than 150 years old. Brave souls sail these waters every day, and each vessel is equipped with global navigation satellite systems and echo settlers if they're big enough. All of this data is only used for navigation, but if it was somehow recorded and shared, we might use it to chart the unknown waters. So, we built a box. It's autonomous, meaning no interaction from the mariner is required. It's able to work offline, interfacing with the ship's network of sensors, recording everything in real time. Then, when they're ashore again, close enough to a 4G network, it will synchronize all of the collected data to a central server. In the summer of 2023, we tested the system for the first time. For 37 days, the system performed flawlessly aboard the Dana. This was the first test of a crowdsourced bathymetry data logger by the Danish Geodata Agency, and it proved immediately useful by becoming a tiebreaker between two conflicting data sets, ensuring that the sea north of Hirtshals is deeper than initially thought. We had our second real-world test less than a year later in the spring of 2024. This test lasted for almost a year, collecting millions of data points for more than 300 consecutive days. This proved that the system is very robust and able to recover after a power outage. The data is not perfect, however. Bubbles confuse the echo sounder, and sometimes sound waves bounces back and forth between the keel and the sea floor, creating a double false bottom. Even the motion of the ship in the waves affects our measurements. So our expert hydrographer marked each of the more than 1.7 million data points either accepted or rejected, after accounting for tides, of course. While we might be able to scale up to 1,000 CSP boxes aboard 1,000 ships, we cannot hire 1,000 hydrographic experts. However, we can build an anomaly detection model using machine learning to do all the hard work for us. So, that's what AIT did. Not only that, but the MapFed model, as we call it, can run in a federated setup. That way, each ship in the crowd has its own model that is improved in real time and works decentralized. The two major benefits to this are, firstly, only the MapFed model is transmitted to the central server, not the raw data. This saves a lot of bandwidth. Secondly, since no raw data is sent, the exact data is not shared directly, increasing privacy for the crowd participants. When compared to a human, the model performs exceptionally well, with an accuracy of 85% of anomalies being detected, depending on the exact model and test area chosen. The system was also integrated into the MobiSpaces common front end, where the anomaly detection module can be accessed via a user-friendly dashboard. With more than 70,000 ships sailing within Danish waters each year, Imagine how fast we could map the seafloor if just a fraction of these ships had a data logger installed. Oh, remember that initial test? Yeah, the data from that trip was used in the second version of the Danish depth model. It's the first time crowdsourced bathymetry data has been used in any official Danish Geodata agency product.
Yeah, okay. So, yeah, I think I explained that pretty good in the video, so I can basically freestyle this from now on. Perfect, right? That's why I wanted this in front of everything else. So yeah, this is Denmark, and what you see here is the EEZ, the Exclusive Economic Zone. That's what we are allowed to use. And this is the traffic that we talked about as well, the 70,000 ships that pass through our waters every year. That's a lot of traffic, and we are in the top 10 around the world, like in terms of traffic passing through. And again, most of our data is interpolated, especially out in the North Sea, where we have as much as 5 kilometers between measurements. So there's a lot of unknowns out there. You will see some slight orange tint in that yellow part, and that's the individual measurements. But can we really rely on 100-year-old measurements to be accurate still today? The seafloor will change, harbors will be excavated, and sand will be moved by the currents. So probably not. More or less the same, but probably not. So what we intend to do is try and see if we can find at least chart discrepancies, or perhaps even use the data for modeling, and maybe even at a much later stage, even charting. So that's what we looked into with this use case. Of course, there's a lot of data in such a thing, so we need some technology to really help us do this. First of all, we need the box that needs to interface with the ship's NIMEA network. And of course, we'll then need to process all of this data, and again, it takes a long time. That little sliver of data you saw that was used in the DDM, that took about 14 days to clean and tide correct and do all of this processing. So if we could scale this up to 1,000 ships, then we really need to have some kind of automation processing going. And this is what we propose here. So each little ship would have its own box with the federated learning model running, and it will have a central model pushed to it, and then sort of correct its measurements using federated learning, and then transmitting the model back. That's our proposed workflow. For now, we're just sending the raw data, and we've only really tested it in the lab. So this is how we integrate into the MobiSpaces platform. So you see the data comes in at the teal boxes below on the left, and then go through the whole ecosystem before it ends up on the dashboard. I'll not spend too much time on this. Here you see the federated learning model used in the lab environment. So this is the test of the federated learning part, seeing if we could actually do it. Because of course we only had a sea trial on one ship, so we needed to test that. And the map-fed model performance, we did various experiments because it's quite easy to do, so we trained a lot of different models. And we found out that one of the better performing models used variable prototypes. So prototype especially is saying something about this area. And how far out does that go, and how much can you actually say about this area. And if you have a very dynamic seafloor, you need more prototypes. And this is what we have here, and it evaluated 150 data points, or 150,000 data points, and it did really, really well in terms of predicting if it was a real depth or not. And this is the sea trial. We used the research vessel, the RV Dana. We put that box on board, and this is the first sea trial, the first 37 days. Later, that was used in the DDM version 2. This is the second part of the sea trial. We also processed this data, and that's the confusion matrix you saw on the previous page. That's built on this data. And then, of course, we continued because the box was running. So why go pick it up? Might as well let it run. And we actually got a lot of data these past half a year until March. And this is actually the entire thing that we covered. 4.3% of the Danish EEC was covered in just a year. So if we scale this up 100 or maybe 1,000 ships with this technology on board, small box doesn't have to be that expensive. We estimate that we could probably cover with 1,000 boxes most of Denmark within a year in terms of data collection. So what does it actually mean? Now, this little animation shows the difference between the first DDM and the second DDM. What you're seeing here is Gaia-X. You have Skagen up there on the top. That's the very top of Denmark. You have the colored lines running through. That's the sea trial data. And then you see how the model actually changed. So our understanding of the depth changed dramatically just by this one short 37-day sea trial. Yeah. So, thank you.
Seem to be the shortest one, aren't I? Thank you very much, Niels. Thank you, everyone who just presented the use cases. This is it's incredible to see it all together in this one day. Now we will dive into the more technical heart of the project. So I would like to leave the floor to Claudia and George. That will now discuss sort of the more technical aspects and the MobiSpaces toolkit. So I'll leave the floor to Claudia first, and then we can pass the floor immediately to George.
So you found the second small person here. The mic is perfect. Please let me know if the distance is good enough for you, because sometimes it's too close. So my part will be quite short, as I just brought two images that I would like to explain to you on behalf of our dear colleague who cannot be here today, unfortunately. So the first one is the data services integration pipeline. The idea here is to have a simulation of how the use case data is retrieved or acquired, let's say, and then processed for better insights, but also to allow us to, grab the most relevant data for us to process it further. So we start here. Unfortunately, I cannot stand right in front of it, but we start here. We go this way, and then back and forth the min.io and end here, just so you know where we start. So first, the use case data is available and required in situ using Kafka. And after a formatting process, making it a CSV file, it is placed in an SQL database and then exposed by an API in order to, prepare it for the next steps in the pipeline. The data is then retrieved by a microservice working as a sidebar that is here to this data cleaning component. So the cleansed data is then uploaded to our project's min.io. And then also the RDF metadata generator is notified that new data is available to be processed. The second sidecar here working along the RDF metadata generator kind of grabs this cleaned data and triggers the generation of new TTL files and then uploads it back to the min.io. And finally, here in this findability part, this component knows when this data is available and grabs the data and automatically loads all the TTLs that were generated there from our min.io, and then is able to generate the final metadata reference for it. So that was the data services integration pipeline. Now let's look at the smart machine learning workload placement. I hope it stays connected. As I mentioned, the data scientist defines an experiment involving several machine learning algorithms and datasets. And the AI workflow builder uploads it as a YAML file to our min.io in the project. And our resource allocator that is running in the Ionos cloud is in charge of deciding the most suitable place for deployment. That is based on the experiment characteristics and the metrics that were gathered from the available infrastructure. And after formatting the experiment accordingly, using the Argo workflows format, the file is re-uploaded, but to a different path in the min.io, providing annotations that we need for the final destination or final environment of our target. And the deployer, the so-called watcher, detects this new workload and deploys it using this mentioned target destination, and it does so by encapsulating the experiment and then using the target environment or destination as namespace, not workspace. Now we should have it.
Yes.
Thank you so much, and next to George.
Thank you. This is. Yes. You can. Okay, works. Okay, perfect.
Hello, hi everyone. I am Sick George. So,
George, you can just put your microphone up there. No, so then I will be good. Perfect.
Now it's okay?
Yes.
Okay.
Yeah. Thank you.
So I will present today some of the technical updates and some technical innovations that we have for the mobility, analytics and processing part of Work Package 5. So let's start. We basically have this initial slide here, where we just mention a bit about our objectives. We basically have two objectives in this case. The first one is to dynamically understand the capabilities of the various compute nodes that we have available. So understanding what each computational hardware piece that we have available can actually support in real time, for example. This will be useful in the following slides. You will see why we need it. And then we need to actually develop dynamic algorithms that actually suit this workflow that we will build, and I will demonstrate in a bit. So let's start with MobiBench. Okay. So the MobiBench suite is basically a suite of tools and algorithms, pre-processing tools and algorithms mainly, that are responsible for providing inputs and outputs for these three components that you see here. Wait, do I have a... Okay. So the three steps that we have to follow that we actually follow during the MobiBench approach are cleaning, augmentation, and compression. The goal for this method was kind of twofold. The initial goal was the one that's mentioned here, to actually benchmark and profile the various devices that we have available. The second goal was also to somehow create and formulate and develop and implement mostly the pre-processing algorithms in a scalable and efficient way that will be used for the second part of the discussion that we'll have. So, you will see here some summaries of the various steps that we take. Some of them are rather simple. You will see we have the simulation of a data stream. We have some simple stuff again, like the duplication, extraction of features. The important stuff here are, for example, the resampling part. Naturally, in most cases, moving objects don't have a very fixed sampling rate available. So resampling them in a way helps us to perform specific analytics jobs. Then we also have other stuff like stop detection, and this stop detection, for example, is also shown here, where you can see that in line you can actually identify stops by identifying slower movement that corresponds to specific areas. Then we have the augmentation part, which is basically includes, for example, segmentation and pattern detection and movement pattern detection. So segmentation is based on the stop detection that we performed in the last part. Based on those stops, we can segment trajectories into different segments, into different trips, let's call them. And then for the group pattern detection part, based on these movements, again, we can actually use specific algorithms that we have, and we also have publications on this, for example, that can detect co-movement patterns. So, for example, moving objects that follow specific routes for parts of their trips. Then, lastly, we have compression. This is very useful in some cases, because especially if you can actually do it in real time and in an efficient way. So if you can do it in real time in an efficient way in the edge, you can actually perform this compression and only share data that you need to share. And this way you can reduce throughput, you can reduce the need for bandwidth, and so on. So this is kind of the important part of this, this discussion. You will see here, let's focus a bit on the images, I guess. You will see here some benchmarks that we have. You will see here some segmentation of different compute nodes, and this is an energy efficient matrix that is useful for a very specific part of this discussion. So, as I mentioned before, the two goals that we had, the one is the rather apparent one about benchmarking. The other one was actually finding and implementing an efficient suite of pre-processing services for moving objects. So, to achieve this, we used basically tailor-made code and the programming language Rust. Even though we all love Python, I guess, you will find that for efficiency and speed, it's not always the best option. So the second part of this goal that we had is basically related to this. So we use Rust, and because we use Rust, we can actually benchmark these nodes efficiently and get very good performance in basically all of them. But in more detail, you can see that specific nodes are more capable than others in the graph that you see in the bottom left. And of course, in all of them, I guess I shouldn't put a lot of time in this, but just so you know, in a lot of them, it's very important to also keep in mind their wattage, so what kind of power they can consume. For example, a Raspberry Pi 4 can consume like 5 or 10 watts. An AMD EPYC whatever can consume like 300. So it's very important to actually keep in mind that we need more power efficient devices for this to work. Regarding the segmentation that you see here, you can see that we have like a cross where on the left side we have the low performance, or on the right side we have high performance, and we also have high and low power in the vertical axis. So you can see that the edge part is where we have generally lower power requirements. Then the middle part, which is basically like the fog part, let's say, is where we have kind of okay requirements for power, and the high part and the part up the top is where we have the cloud part, which is where we need a lot of power, we need server-grade hardware, and where, for example, AMD EPYC processors are being placed. You can see other processors here, and that's more or less it. So, why did we do all this? Why was all of this needed? The rationale behind this was we would use these tools, to actually enable us to perform some sort of innovative analytics approach, innovative analytics method. So this method for us is FLP, so future location prediction is what that means. There are a lot of reasons why this matters, like, for example, collision avoidance, route optimization, whatever. So I guess it's pretty self-explanatory that kind of being able to predict where a vessel will be after like 15, 20, 30, 40 minutes can be useful. So The general approach that we follow here is that we transition to a non-centralized approach. So we transition to an approach where instead of gathering raw ice data in a centralized manner and then providing future location predictions, again, in the centralized hardware that we own, we try to provide models that do so in the edge. This is not just so you're not, I guess, confused regarding the federated learning part. This, unlike the federated learning part, is a model that is completely offloaded to the edge. So retraining can take place at the edge, predictions take place at the edge. There's no need for centralized compute. I guess federated learning does need some sort of a centralized compute, but again, just so you have have this in mind. So this is more or less the architecture of the future location prediction method that we have implemented. In the left-hand side, you see our inputs, which is basically location and time, and also the ID of the vessel. I must have forgotten to put it here. Then some feature creation. You will see that a lot of those are also present in the MobiBench suite. Again, that's why we created it, basically. Then we have the modeling part, which is based on XGBoost. We picked XGBoost. XGBoost is kind of a very well-known gradient boosting method for tabular problems. We know that it's very efficient, and we know that it's very good when you can provide it data that it can understand, let's say. So we picked it for that specific reason, and then we received predictions from the model in the form of delta values. So we predict the change in space for both the longitude and the latitude of a moving object, and we add this to their current position and we get the predicted position. This is a table and some information about the features that we have available. You will see many features here, like simple ones, like the type of vessel and stuff, speed, bearing values, and so on. Some interesting stuff include the extrapolated differences. So we try, like using simple linear extrapolation, we try to understand where the ship might be by just extrapolating it based on their speed and bearing. We also have the origin value. The origin is basically the port you can think of for ships, or a point of interest in any case, where the moving object started its current journey. This is very interesting, especially, for example, in the context of maritime movements. And of course, we also have a very important feature here, which is the prediction time horizon. This we can change to get different predictions for different time horizons. So if we put it like at 60 minutes, we get a prediction for 60 minutes, and so on and so forth. You will see here 3 data sets that we actually used. We have the Brest data set, the Piraeus port data set, and the Aegean data set, 3 specific data sets that also have been used in relevant publications, so we needed to use those to actually validate what we have. And the hardware that we used include a GPU server, which is basically the stand-in for cloud computing, a NAC i7 Intel machine, which is basically like the fog, if you want to think about it this way, and the Raspberry Pi 4, which is the ultimate edge hardware node. So these are some results. I understand that it's a lot of numbers, so just for me to summarize it a bit, the results at the bottom are the accuracy, so the displacement error, basically, of each model, and up top are the performance results. So regarding the displacement, when compared with state-of-the-art, we are pretty much trading blows. So you can see that, for example, in one dataset we are rather worse, for example in Piraeus. On the other hand, for the Aegean dataset, we're much better. And for the Brest dataset, it's like we trade blows every 10 minutes. So I would say that the accuracy figures are pretty much, very much comparable with state-of-the-art. On the other hand, if you take a look at the performance, you will see that our performance is significantly better. So it's possibly even 100x for training, and for inference it's more than 10x in most cases. So this is very much tied to the idea of the edge-focused part that we present. Also keep in mind that these figures that you see here, the training and the inference, for our method is based on a Raspberry Pi, which is like 5-watt device, for those who don't know, very cheap, like 40 euro or something, 50. And for the other model, it's on an Intel Xeon processor and an A100 GPU. The computational difference between those is like chaos. It's insane. It's like 5 teraflops machine against gigaflops or something. So the fact that we are 10x better with such great difference in hardware, it's very indicative of why this is innovative for us. This is an example of the integration between MobiBench and FLP. You will see here a simple data model, this data app, sorry. This, again, this is more of an example, more like a proof of concept, where you can see that, for example, we have some results for the prediction of trajectory. Just so you know, all these results are the result, the predictions of specific points of this trajectory. So, for example, for the first, you can count them like 6 points. The model only gets as input the very first point of the trajectory. So if we just know where the ship, for example, in this case, is, we can actually understand where it will be, even though it's kind of stationary at the beginning. It's just just exiting the port. You can also see here some explainability features and so on. Am I okay on time, or am I gonna get the look? Okay. And lastly, a hint about MobiEdge, which is the key exploitable result of this presentation. The MobiEdge, you can think of it as the system behind this whole thing. We had MobiEdge, where we identified the hardware capabilities and created the methods that fueled the FLP method that predicts the movements of vessels. But we also need kind of a system to go to include both of those offerings and to actually make them suitable for the edge. For example, having communication in mind or deployment in mind. So to achieve this, we have introduced MobiEdge, which is basically the key exploitable result that you will hear more about after these discussions during the panel and during the next slots that we have. But the heart of MobiEdge is that we plan to have it exist as a framework, let's say a platform for edge analytics, and it needs to be cost effective. That's why we use these specific hardware nodes, for example, the Raspberry Pi that's very cheap. It needs to be autonomous and resilient, so no need for external hardware, no need for an internet connection that allows us to actually use cloud infrastructure, for example, just edge processing. And it also needs to be innovative, so it needs to be able to support an ongoing works on edge analytics. And this is what we actually show that we can support through the performance figures that we have. So if we can support thousands and thousands of concurrent moving objects, it's rather simple to understand that we can add layers of communications on top of what we have, and we can still support maybe hundreds. So that's the idea behind MobiEdge. I think that's it. I hope I didn't take too much time. Wait, I have to disinfect this because...
Thank you so much, George. Thank you, Claudia, and everybody else who presented. Does anybody have any questions for our panel? We do have, I say, 4 minutes. If anybody has any questions from online or here. Otherwise, I'll just take a couple of seconds to... Oh, there we go. Perfect. Thank you. Yeah, if anybody has any questions. Anyone? If not,
I would like to have one last round of applause for the technical developments and use cases of MobiSpaces. Thank you very much, everyone, and it's great to see how sort of the knowledge that we've generated and the technical developments that we've created in this project sort of intermingle and sort of contribute to the whole success of the project. So thank you very much, everyone. So we'll now have a 15-minute coffee break, and then we will come back and we will have our panel discussion. We will hear from representatives of different European projects and initiatives in the European Union to see what's the MobiSpaces legacy, but also how it fits within the data spaces and green mobility ecosystem. So enjoy your coffee, have a glass of water, juice, and we'll see you back here in 15 minutes. Thank you very much.
Thanks everybody for coming back. Hope you feel refreshed after this little break. We're now going to have a panel discussion. We've titled this discussion the Data Spaces Landscape Insights from EU-Funded Projects and Initiatives. And I would like to invite to our little stage our panelists. So can I please have Johannes Unruh from Gaia-X for Future Mobility, if you would like to join Matteo on the stage. Thank you very much, Johannes. And then also Lauretta Tosca from the Tango project. And if I'm not mistaken, we should also have Pierluigi Plebani online, joining us remotely from Politecnico di Milano. Can you hear us, Pierluigi? Give us a sign.
Yeah.
Perfect.
Morning, everyone.
Thank you. Okay, so welcome everyone. I think a round of introductions is due. So maybe I will just quickly go around and ask you all to introduce yourselves. So as I said, we're here to discuss what the landscape for data spaces and green mobility looks like at the moment and what we should be looking forward to. So to hear from stakeholders in the ecosystem, I would like to pass the floor to Johannes to please introduce yourself and tell us a little bit of your background and about Gaia-X for Future Mobility, and maybe clarify for us what's the difference between Gaia-X for Future Mobility and Gaia-X. Thank you, Johannes.
Yeah, thank you very much for having me. It's a pleasure being here with all of you. My name is Johannes Unruh. I'm from the German Aerospace Center and therefore from the Institute for AI Safety and Security. So we coordinate the Gaia-X for Future Mobility project. And what is Gaia-X for Future Mobility? So it is a project, a lighthouse project by the German Gaia-X hub, and it is funded from 2021 to 2025, so we are now also in the ending phase. And it includes 6 sub-projects. So we have Gaia-X for KI, for AMS, for ROMs, MoveID, PLC, AAD, and also Ageda. We have over 80 partners from industry, from public stakeholders, and also from academia. And it is really important to note that Gaia-X for Future Mobility applies the Gaia-X principles that are developed by the Gaia-X project. So Gaia-X for Future Mobility is about the cars industry, it is about mobility on the road, and Gaia-X is more of a broad project. So we have different categories in Gaia-X, like healthcare, finance, and also energy, for example. And it is really a European project with Gaia-X hub in all of the different countries. And in Gaia-X for Future Mobility, we have more of a vertical path, and we focus on the mobility sector. So what do? We implement the core services and deployments that are real use cases. For example, we have identity management for the security of the automated vehicles. We have digital twins for automated vehicles and remote operation systems that are developed in the individual use cases, and also infrastructure-aided automated driving. So the focus is on connected and automated vehicles, especially in the rural and urban areas, because that is the most impactful event if we if we change the mobility there, and if we go to the mobility of the future in this categories. So in Gaia-X, the rules and the architecture and semantics are created and developed, which are used for data exchange. So for Gaia-X, it is all about defining the architecture, and then based on that, in Gaia-X for Future Mobility, we use this architecture to deploy then the real use cases. So you can think of it what we have in Gaia-X for Future Mobility in 3 layers. So we start from the infrastructure, just the roads, parking spaces, also the sensors on the infrastructure. Then we have vehicles, which can be automated, semi-automated, or fully autonomous vehicles. And then we have the cloud. And all of these 3 layers need to communicate with each other. And for this communication, we need a common understanding. How are the data formats? Which standards do we have? And these standards are developed in Gaia-X, and then in Gaia-X for Future Mobility, we implement real use cases based on these standards.
Thank you very much, Johannes. And thank you for clarifying that difference. I think that was very important to sort of understand also who we have on this panel here and what kind of infrastructure you're representing today. Roberta, maybe I can pass the floor to you. If you could please introduce yourself and maybe in brief tell us what Tango is doing, what the Tango project is doing, and how it's contributing to secure and trustworthy data flows in the EU.
So hello everyone, also from my side. My name is Roberta Tosca, working at Eco Association of the Internet Industry in Germany, but today here I am as a representative of Tango project. So Tango is a project from Horizon called same cluster as MobiSpace. And yeah, it's a club of developing technologies and data, as the name says itself, technologies acting as a gatekeeper between data flows and informations. So Tango has been developing technologies that follow the federated approach and decentralized concept. Started on 2022, now we are approaching the end of the project, and these technologies are not just written down or some code in the repositories, but these tools have been implemented in the real use cases that we had within the project, such as smart mobility, hospitality, manufacturing, and so on. All the technologies have been developed based on European law, following GDPR regulations, and also taking into the consideration Gaia-X frameworks and other frameworks from different data spaces, which for the future use of these technologies and having interoperability is a key thing. So yeah, this is in a nutshell about Tango.
Thank you. I can already start seeing some patterns and interesting connections between our panelists today. Thank you very much. Maybe I will pass the floor to Pierluigi online before passing the floor to Matteo. Pierluigi, would you like to introduce yourself, maybe your role in TIDAL, and maybe tell us a little bit more about what TIDAL has been doing in the data spaces domain, and what's the project's maybe biggest contribution to energy-aware federated data lakes?
Hey, thank you very much, and thank you for your invitation. I'm sorry to not be here in person, but you know, there are several businesses around in this period, especially for people that are in the academia, because we are in the middle of the exam sessions. I'm Pierluigi Plebani, so I'm associate professor at Politecnico di Milano. I'm here representing one of, let's say, the friend projects, because we are belonging to the same call as Tango, Trustee, and also MobiSpace. I'm representing TIDAL. The goal of TIDAL, in a nutshell, is to make a secure, efficient, and sustainable data sharing among organizations organized into a federation. So security, let's say security and privacy, efficiency and sustainability are the 3 keywords in TIDAL. And at the beginning, the idea when we wrote the proposal is to focus on data lakes. Data lakes as the way to host and to manage data to perform data analytics on top of it. And one of the peculiarities of TIDAL is not to address, like in case of MobiSpace, a specific data space mobility, but to provide a tool set that was able to be used in many data spaces, potentially to all the data spaces that have been envisioned by the European Commission, from the healthcare to the mobility for sure, to the green and to the industry and so on and so forth. Because what we would like is to propose a tool set that is able to make the data sharing easy, data sharing for analytical purposes. For this reason, we focus on data lake, and we moved from the beginning, this initial idea of the data lake, to a data mesh approach. Data mesh has been promoted, especially in the last years, as a good way to share the data, to make the data available to different organizations. And this goal, it is resulted in this tool set that is somehow already compliant with the idea of the data space supporting center, because also in these the blueprint that have been released in the latest version by the working group on, if I'm not wrong, on the last October, we adopted the idea of a data product as by the definition is called the architectural quantum, as the component that hosts the data and makes the data accessible according to the FAIR principles, findable, accessible, interoperable, and reusable principles that are kind of important, especially in the European environment. So the goal of TIDAL is to support this verification. So indeed, the data product means that the data that I would like to share as an organization to other organizations inside the data space, so inside the federated environment, should be properly curated in order to make it findable, properly described, and accessible in an interoperable way. So for this reason, along with the idea of data mesh, we also adopted the classical principles of service orientation. Because with the service orientation, we have the idea that we have a data provider that makes, in this case, not a service, but a data as a service, as a product, available to all the potential consumers. And these potential consumers may be able to find the data, access the data through a standard interface. In our case, we adopted the typical REST interface based on OpenAPI, and we extend the OpenAPI also to capture policies that are able to contain information about the authorization. So in this way, we would like to enforce also the data sovereignty. Data sovereignty is kind of key cornerstone also in Gaia-X. And I think that for this initial introduction should be enough.
Thank you very much, Pierluigi. That was very thorough, and I love the word verification. I think we'll ask you maybe a little bit more about that later on. And then last but not least, of course, we've heard a lot about MobiSpaces already, Matteo, so I'll actually ask you a little bit more of a high-level question, if that's okay. And the question would be, what do you think, we've spoken a lot about data lakes, data spaces, what do you think is the market readiness of data spaces in the EU?
The developments on data space concept have been pretty significant if we consider that now we are in a more deployment phase, but targeting the market is still a challenge. So this is just the very brief answer to this question, but going a bit through it. So first of all, data spaces, for those of you who are not really keen on this concept, are environments that aim to be interoperable in the data exchange. Also, they want to guarantee some sovereignty over the data that are exchanged. And this is, of course, a challenge that aims to be compliant by design. So the very key aspect of it is that the data are exchanged in a compliant way. So we are jumping the aspects of and the burden of checking and verifying that everything is compliant. Aside from that, when we talk about the market, we want to have something ready, something to offer the clients, our clients. And this is still a concept we are going to present. But there are many pilots on it. There are clear architectural standards. So a lot has been done via blueprints and thanks to the work of the Data Space Support Center, the International Data Space Association. They've been very active. So under the terms of how to implement data spaces, we are on a good track. Now, what we would like to have is also data spaces that are interlinked, which is yet another challenge. But for the time being, some successful examples are like the mobility data space in Germany. There is an interesting case led by Airbus as a data space. So it's a very innovative concept that has been taken seriously by many different actors. And in Europe, we are for sure an example, and we are leading this concept. So I hope I've given some insights. But yeah, under the market readiness, there is still a lot to do, but the horizon is optimistic, let's say.
Okay, great. That makes us a little bit more optimistic for the future then, and we still have work to do, and we can sort of keep moving forward in that direction, hopefully. Thank you, everyone, for this brief overview. We'll maybe move on now to a more to a part of the panel that has more to do with synergy and cooperation and interoperability and so on. So maybe I'll come back to Laura with a question. So you have also some experience in the open source community. What do you think are the biggest obstacles when it comes to knowledge sharing and knowledge exchange within the EU data spaces ecosystem?
Thank you for this question, Roberta. Actually, I'm leading also Gaia-X Federation Services open source community in Eclipse Foundation. So it's an open source community that worked on developing technologies. But when we come to open source, I see that people are hesitant, and I see the only reason is that a lot of work is being done. Everyone works in their own projects, in their own initiatives or companies, like in silos. So I would recommend that instead of reinventing the wheel, to look what is in these repositories and build on top. This way we move faster and we don't waste time and resources, of course. One of reasons why this is happening maybe is because of lack of documentation. We are so focused on developing and doing things and trying to be on time, but documentation is key. If we want to take this knowledge to others, then we should have proper documentation on everything what we do. So yeah, I would suggest to everyone that is developing technologies or even describing a use case to have a proper documentation of it, so the others can look what is there, make use of it if they need, and bring things to the next level. And also another thing is that we focus also in just our own use case or being very specific in one sector. When it comes to new technologies, we should be more generalized. So for example, developing a wallet just for a single use case when we don't have other decentralized wallet, it's not the case. So I would recommend that we also, this is very good when we are specific, but bringing technologies also in more general way that can be used also in other use cases or domains.
Thank you. I think that's a really, really good point. And maybe that's a comment also for our MobiSpaces partners to make sure to have proper documentation, which I'm sure they're already working on our open source software hub, which you can find on our website to learn more. But I absolutely agree that it's not just about sharing, but it's also about the metadata, all of the information that we can provide on top of it, so that it makes all of the information technologies that we're developing more usable, findable, and all of the things that we discussed earlier regarding fair data principles as well. So thank you very much for the question. I don't know if anybody wants to comment. Of course, feel free to stop me if you want to comment on any of these questions that I am asking. I will maybe then pass the floor to Pierluigi again. And I wanted to ask you, Pierluigi, so we've spoken in the past about, and you mentioned this earlier as well, you've been working intensely on the implementation of fair data principles within the Theodoropoulos project. What do you think are the challenges in the EU when it comes to verification, which is the word I was lacking very much earlier? What do you think?
Yeah, the challenges are many. So even if first of all, verification, fair principles as their principles are defined. I'm not saying in a vague way, but for sure they are not defined in very precise way. It is not a defect. It is not a weakness of those principles, because being principles should be inspirational for something. But at the same time, it's not somehow easy to really create techniques and technologies that are able to enforce these fair principles. First of all, if I'm talking about findability requires the ability to include, to describe data sets using metadata. And metadata are very domain dependent. So there are some domains, for instance, the healthcare, that are more, I would say, mature in this sense, because there are some ontologies, agreements, standards like OMOP, FIRE, and whatever, that provides, let's say, a ground on top of which we have already an agreement between different organizations, and to specify in this way metadata that are agreed by anyone, at least the meaning of this metadata. There are other domains in which this agreement doesn't exist. So one of the key points about the findability is this one. About the interoperability, it is true that if we rely, like in TDAL, on OpenAPI, because we would like to adopt a service-oriented approach, then interoperability somehow is guaranteed, could be taken for granted. But the problem is related to the interoperability when we are looking to the governance, to the data governance in the federated environment. How we can express constraints related to the authorization, the number of access that a client could have. So all these elements impact a lot in the real adoption of these technologies and the real concretization, realization of those principles. But like what Matteo was saying, it is true that there are many challenges, but I see that the horizon is, I would say, bright. It is optimistic, because I would like to recall to whom has participated to the ADBF forum on the last October. I remember that most of the projects that were involved in this cluster was kind of skeptical about the real adoption of our technology in the pilot. We were everyone scared about I'm not saying the resistance, but the deep gap that we have between companies, so people that can work on it, and our proposal. I would say that even if I was kind of skeptical too on October, only 6 months after, while we are approaching the end of the project, I just realizing that the companies are much more mature. Probably we were able to be very convincing. And I saw that they understood the problem very well now, and they are easily going to adopt what we are proposing. It could be for sure a success for TDAL, But I'm saying it's not a matter of data, but probably also company in the meanwhile that realize that they have this problem in sharing data, but also the opportunity to share data. So data sharing became something that it is implicitly understood as a big opportunity for the companies, besides all the other problems related to the trustworthiness and sovereignty that are aspects that needs to be taken into account.
Thank you very much, Pierluigi. I think those are all really valid points, and it should be, as you say, like seen as a resource, seen as an opportunity to have open data. I would like to ask Johannes another question. Now that we're speaking about sort of synergies, cooperation, interoperability, and data sharing, what do you think are best practices that projects like the ones that we have represented here today should adopt to better cooperate and align with existing infrastructure? So, for example, what has worked well in Gaia-X for future mobility projects, for example?
Yeah, thank you very much for this great question. So to start with, I want to do it on an example project, which is called Nemobil, and it's also a European project where we develop automated vehicle transport, so public transport. And yeah, you have to imagine like you are in a rural area, you live there, and then we have 3 working packages, or 4 working packages actually, but that's the modular approach. And in one working package we develop an automated car, which is a big car, which is called Nemo Pro, and then we have a working package where we develop a small car that's called Nemo Cap. And then the idea is that you have individual starting points, and the Nemo Caps, you can, as a user, you can book via an app, the Nemo Cap. It comes automatically to you, and then the Nemo Cap, all the Nemo Caps from the individual starting points go together to a meeting point, and there they can connect to the Nemo Pro, and then they go together, coupled in a coupled way, the long distance, for example, on the highway, and then in the individual destination points, they disconnect, and then they can move to their individual destination points. So in this project, we had some values that we tried to follow, and I think pretty successfully. And I'm also very happy that you said before, like use open source components, look after your documentation, because that is also what we exactly did. We used the Eclipse database connector, where we in the 4th working package about the digital infrastructure really used to get the connection to the data space. And that's really important, because you don't need to develop everything from scratch. That would be my first advice also. Just look what's out there, look what's already developed, and then build from that. And I think also the documentation really has improved a lot in the recent times. I remember when I started like 2 years ago to work on this, there was no documentation at all, for example, about the Eclipse database connector, or at least not as much. And now it's really easy to get onboarded, and now there's a lot of good documentation out there. So it really also improved. And it's also a lot easier to just don't develop everything yourself and look what's out there. Then it's really important to have a modular architecture. So for example, we have the route planning service, we have the data space connector in a different module. Then we have the connection to external sources, like for example, weather information, road conditioning, and everything of this. Also in a separate module. We have simulations which are done by other universities in a separate module. And this way, if you have everything modularly, you can work independently on these modules, and then at the end you can connect this, and like this you can work in a very efficient way. So this would be my other tip. And then also trust by design. and security by design, I would start from the beginning to really look after the security at privacy-enhancing technologies, like for example secure multi-party computation or homomorphic encryption, because this way you will really get also trust from the user, and the user will only use your system if the user can trust your system. And that's actually my next point, to have user centricity. So always have the user in mind when you design your project. Like do user-centric stories from the beginning, and also along the project always ask yourself, okay, what will the user think about it? What is actually the benefit for the user? And really, develop these user stories and go from there on. Yeah, that's in a nutshell.
Thank you. I think that was very information-packed. It's hard to summarize it, but I think my favorite one that you've mentioned is probably don't work from scratch. Don't start from the very beginning. Avoid the repetition and the replication of efforts. That's so important. But yeah, thank you very much for that overview, Johannes. I don't know if anybody wants to comment or add anything regarding sort of recommendations of what has been working well in this area. I would also maybe like to mention now that we are hoping to have a workshop regarding how can we, as a sort of a cluster of projects, build more synergies and more best practices and recommendations for other projects and for policymakers on this. So stay tuned on the MobiSpaces social media channels to learn more about this in the future. But I think that's a great starting point, Johannes, for sure. And then maybe I'll pass the floor to Matteo again. So we've spoken about privacy preserving and trustworthy data infrastructures. We've also spoken about open source. What do you think are the biggest challenges in providing both approaches? So from the open source perspective and the privacy preserving data infrastructure, how can they coexist? And what's the most challenging thing about it?
Well, that is the challenge itself, in the sense that on one side we want to have an open source approach, so giving the chance to see all coding lines, to try to verify each and one of them and try to verify what works, what doesn't. But on the other side, there is privacy preserving issues, because you need in any case to ensure that what you are working on is granted of privacy. And this is by definition encryption we talk about. So on one side is kind of decryption, and on the other side is encryption. So this is the toughest challenge, to try to find a balance between the pure transparency that is of course needed, because the research community relies on open source, and also the contribution of open source to the entire community, even business, is of great use, because there are many solutions that start from open source, very nice tools or ideas, let's say, and build up from there. So yeah, this is undoubtedly the biggest challenge, according to my perspective, of course.
I absolutely agree. It's a big challenge also because when we speak about mobility, often there's human beings involved as well. So there's a lot of the data often comes and needs to preserve the privacy of individuals and then their daily activities. So yeah, absolutely, that's it's a big challenge for sure. Okay, so now moving on to maybe the latest, the last part of this conversation, and I promised we would be looking to the future of the ecosystem. So this is that time. We've already said that the horizon doesn't look too gloomy, that there's a lot of optimism and hope for the spaces ecosystem in the EU. But I would like to sort of ask a question to you all. So you decide, whoever wants to go first. And the question is the following. So in the EU, there's been a lot of fervor, especially recently, regarding removing some of the red tape that is slowing innovation. You know, there's a lot of conversation about how can we be more competitive, how can we accelerate innovation, and some of that needs to come across the removing of some of the obstacles. So in your opinion, what would be your main recommendation for policymakers and people in policy to accelerate the move towards a more interoperable, standardized, and trusted mobility data spaces in general, and or, depending on your background, on your domain, smart mobility solutions across Europe? So I'll summarize it because I've spoken for a very long time, but what would your main recommendation be for policymakers to accelerate innovation and remove some of that red tape? What needs to be done? Who would like to take this? Lauretta? Yeah, of course.
I can start shortly, as currently I'm working in another project regarding SLAs, so service level agreements, because we saw the need there that policymakers, instead of coming up with new regulations or standards, they should work in a joint interoperable framework. So with the emerging technologies and AIs, cross-border service providers can easily cooperate and also make life easier for users. For example, we have a use case illustrated in this project. Imagine it's happening now or in the near future. One autonomous car driving from Madrid to Budapest. So instead of receiving billions of invoices and changing the providers and struggling with all these services during his journey, from the start to the end, at the end, this user or driver will get just one invoice. And this will be possible only if we have service level agreements. So I would really recommend that policymakers and also Europeans work on joint interoperable frameworks.
Great. I think that's a great start to service level agreements is the way to go. Anybody else want to take this? I don't know, Pierluigi maybe from home?
Yeah, I completely agree with what has been just said. I would like to take more, let's say, a technical perspective. I'm not a policymaker, but I think, and it is aligned to what she has just said. I think that we need less regulation and more framework. I would translate into it's better to approach the problem in a according to a bottom-up strategy than a top-down. I'm talking about, for instance, about data sharing. Instead of building a new solution, I would say a centralized solution that and ask to all of the organizations, you have to use this solution in order to make possible the flowing of the data between different organizations. I would be more, let's say, on the software-oriented approach. So you can do whatever you want inside your organization. Let's define very few rules, very few that agree on some few standards, and as soon as we agree on those standards, we know that we talk each other. Because if we look to the success story of the service orientation, so the interoperability at organizational level that we had in the last 25 years, because we are talking about service orientation about at the end of the 90s, just to solve a simple problem at that time. So the problem was simple, the solution was not so simple, but the problem was simply, I need to connect my information system with the information system of another organization. I would like to take advantage of a new, let's say, of a new infrastructure that's called the web. At that time was kind of new. So they simply said, okay, let's focus on the description. We had WSDL, he had a lot of limitations, whatever. after a while we had REST. But the principles remains the same, and now everything is connected and is interoperable because we just rely on a few ideas that are agnostic with respect to the domain and can be easily adopted. I think that the key point should be the same also if you are talking about the data sharing. We need to identify, for instance, what do you mean with the sovereignty, which are the policies, SLAs, we can translate into SLAs. Defining the SLAs is kind of important. And I would say to bridge the gap between, when we're talking about SLA, let's say the legal perspective and the technology perspective. And I see that the AI, natural language processing, has the ability to give us a big help in reducing this gap. The gap will exist forever, but at least to reduce this gap.
Thank you. I love that we've had a more policy-oriented perspective, also a technical perspective, and I like the idea of a bottom-up approach. You know, establishing best practices, what works, so that we can then inform policy and support policy making from the bottom up. Anybody else wants to comment? Yeah, go ahead, Johannes. Or Matteo, yeah.
Yeah, I'm gonna be like in between the two previous
we love it
intervention. Yeah, because policies are cornerstones of what we do, actually. They even generate business if we look at it closely. So less bureaucracy and more action would be the synthesis of what has been said by the two previous panelists. But I would also go beyond the technicalities. So I would consider the user as the center of the change, let's say. Because every time we talk about policy, there is somebody who needs to adopt it and somebody else who will benefit from its adoption. So we have to have a clear pipeline, and on that side, we always have to take care and take into consideration what is the kind of user benefit and user friendliness of what we are doing. Because my perception is that often we get too much technical, GG sometimes maybe, and some other times we focus too much on what the laws are requiring, and the one left out is the end user. So that's my point of view.
I think that's very interesting, and it kind of creates I'm gonna say a pun now. It's gonna create a space for the user in there. So instead of being a line going back and forth between policy and technology, it now becomes a triangle with the user, and there's a space in the middle. That's my I'm gonna make an infographic about that. I think that's great.
Yeah, and if we have interoperability, everything works. So
exactly. So I appreciate that we need to take all stakeholders into account, and they can all contribute to the sort of informed decision making, for sure, on all ends. Johannes, would you like to comment on that as well? Yeah.
Yeah, I mean, I let you go first because you two already said what I also wanted to say, like reduce bureaucracy. I think especially in the NemoBee project, I think we did great, but we also noticed that bringing an automated car really on the road, you have to fill out a lot of forms, a lot of documents, you have to wait a lot, and you have to do a lot of proof that it actually works and so on. I think it's just too complicated, and maybe a solution would be to designate a special area where you can make this process faster. So maybe some streets or some place where you can have this test automated vehicles really driving. So we had cooperations in the Nemobil project with TÜV from Germany to really get it really fast on the road, and I think within next years we can get the cars actually on the road. But yeah, in general, I would agree to both of you, like reduce bureaucracy. It's a key point.
Thank you very much. So once again, looking to the future, maybe one last question for all of you. And looking once again at the optimistic horizon in front of us, what are you finding most interesting and exciting looking to the future of this ecosystem, of the data spaces and mobility ecosystem, in terms of opportunities for innovation, but also synergy between industry, research, and other stakeholders? Who would like to start? Yeah, Roberta.
To be honest, I see a lot of opportunities, and it's super exciting coming just from the very first idea that we are switching now from one concept to another completely. So it's completely a new universe or data space also for Europe, where we now are just, I say, doing research, because some are there, but still with emerging technologies and AI, we first need the infrastructure, then we need the data and everything then to manipulate with AI. So there is a huge potential, and it's exciting, and I think we are on the right direction, and AI would help us, and whatever we have been developing all this year will be much easier, but to bring that to the AI level, we had to do this work.
Thank you very much. Who would like to go next? Maybe I'll do the same as earlier. Pierluigi, do you have any insights, anything that is exciting on the horizon in the coming years?
Yeah, for sure, but I think it is already somehow established and envisioned. We need to move from domain-based data spaces that are kind of, I'm not saying silos, but they are now addressed singularly into a more complete and heterogeneous data space in which different elements taken from different data spaces are combine each other. I think that this will be full of critical and challenges. I think this could be something that is very, very interesting on some directions. And what I see really interesting on the other side is to go beyond the European Union. Because even if we are talking about US or talking about other parts of the world, they have a different even perceptions of what is privacy, for instance, what is business criticality. And I think it could be really challenging and interesting to address also. It's not only a matter of technical perspective, but also cultural perspective. And mixing up these different things could be really nice, in my opinion. Have no idea how to address it now, but it would be interesting.
We'll ask you about that in a few months, see what you come back with. Thank you very much, Pierluigi. Anyone else? Matteo?
What I find really exciting is, first of all, as mentioned earlier, the fact that this is a new paradigm. So whenever we have a new paradigm involved, there's a lot to study, a lot to experience. So that is per se something I find exciting. But apart from that, is that if we manage in completing the roadmap towards talking about data space as if it was like the weather, kind of, the impact that this can have in easing many different dynamics between businesses and their own needs in data sharing and in collaborative domains, such as, of course, international projects, I think that is the most exciting thing, because the fact that you'll be able to exchange data with a click, but in the sense that also in a with the let's say the confidence that you're doing something that is compliant. So you'll not have troubles. You'll not get into troubles. I think this is a very positive side of it.
And I also would like to reiterate what you said about, and what Roberta said earlier about when there's a paradigm shift in technology, we have to iron out the wrinkles first, understand where we are, and then we can move forward. And that's where we are. We're on the edge. We've ironed out all the wrinkles. Now it's time to move forward. So I absolutely agree. Niels, would you like to say anything?
I fully agree with you. It's very exciting, this new paradigm, but it's also not too new anymore. I mean, we are also in the deployment phase. When I started, it was a lot of theory because it's also very complex. And now we really have deployments in the cloud. We have connectors working. For example, also in the Gaia-X project, there is industry from a lot of different car manufacturers really also using this technology right now. And it's different than just a global player comes and says, okay, I have this technology, now use it. But this one is really different because it's community-based, it's decentralized, and I think it's really great to see all the different stakeholders come together, build something together, and also make it open source so that everyone can contribute. I know it's sometimes maybe a little bit more complicated that way because you have to discuss a lot, you have to agree on certain standards. But I think it's worth it, and I think it's really nice to see all of this community effort and the different companies and stakeholders play together and really accomplish something like this. It's really great to see.
And that makes it very exciting, absolutely. And I think that there's a really nice point that you made there, which is to see decentralized as an opportunity and not necessarily as an obstacle to innovation. Great. We're slightly ahead of time, but please, everyone, give a round of applause to our panelists for such an insightful discussion. And I think we had a lot of different perspectives, and we definitely have something that we can build on, and for sure there's more synergies to be established amongst us. And as we progress, some of our projects are ending, some of them are a little bit earlier in the process, but hopefully there is a legacy that we have established here today that we can sort of bring forward. Yeah, maybe I will now shortly leave the floor to Matteo for some closing statements, just some information about the rest of the day today. And I would like to use a metaphor with our lanyards today. So hopefully we have planted a seed, if you will, today for innovation, and we'll make sure that it keeps growing and it keeps expanding and it keeps proliferating. And as you can see, our lanyards are made of seed paper. It's biodegradable paper. There are seeds in it, and if you plant it in your garden, it will grow wildflowers. So we like to use this metaphor for leaving you with a positive message today as well. The day will progress now with after the closing remarks, our lunch break, and then in the afternoon we will have a co-creation workshop where we will have the opportunity for our panelists and other guests here today to introduce other initiatives and stakeholders in the ecosystem, and to give us their feedback as well on some key MobiSpaces innovations, which will be presented later this afternoon. So it's not over yet. There's more to learn about MobiSpaces and more to tell. But I would like to leave the floor to Matteo if you want to say any closing remarks. Thank you very much.
Thank you very much. Yeah, you'll have enough of me speaking after this morning, so I'll be brief. I really want to thank TrustIT for the impeccable organization of this event, and to all, of course, our partners who contributed to make this happen. I really wanted to have this kind of event because I think it was a great occasion to showcase the results of our effort that are not finished yet. So up until the very end, we will continue try to boost our results on the data space domain because we really believe on this mission. And it was a real pleasure to have some other external stakeholders that gave us their point of view and their perspective, because it's been very constructive in my point of view, and also it's enriching every time. I also know there's been a huge participation online, so I really want to thank the people that took the time to hear more from us and on our project. And I think that as a summary, let's say, of what has been said today, we could say that there is a lot of people working on this topic, a lot of people working on this, on many facets of this main challenge, that is bringing data spaces to ordinary life. Let me say, rephrasing this. And I think we are on the right path. What I hope is that this can really enlarge the adoption of data space also beyond Europe, because I believe it's really an enabling factor of many activities and many business opportunities. So having said that, thanks a lot also to the European Commission for funding this project and many of the projects we have been collaborating with, and also not collaborating with, but in any case we have been spotting throughout this journey. And I hope it will continue funding research and innovation on this topic in order to make it happen. Thank you all, and have a nice lunch break. Thank you, really.